Okay, this is a continuation of some demos of the stuff that I've been working on with this application. I did this video, I guess about 3 weeks ago now, that kind of explained the basics of this application. I'm not going to revisit this, so if you're confused about anything, go back and check out this video. I'm just going to, kind of show you what kind of the next stage of my development's been like. Okay, so this is the picture I showed in that video. So yeah, again, we got this window here is the twisted WebSocket server that's serving the browser client, the client up here, multiple clients potentially, and then yeah, the REST API backend is this window right here. Okay, so when I showed this video 3 weeks ago, one thing, there's a little bit of a cheat here. So the key thing when we're dealing with Lightning invoices, and you got an application on top, is you need to be able to notice when they're paid. Like the Lightning Network has its own peer-to-peer interface, so like payments come in out of band from the application. They come over the peer-to-peer interface, and then see Lightning's like, oh hey, there's a new paid invoice, and then this application has to notice and then respond accordingly. So the cheat I had in the previous demo was that I have this mock C Lightning just replaced in for C Lightning, such that I could quickly mark something paid. Now the cheat is that when I make an invoice, I got the Bolt 11 coming back up to the client, but then I made a button that said, hey, you can mark as paid. And when it marked paid, it would cheat and then go ahead and rediscover the state. Just because it knows, like, hey, I've marked something paid, and then that must mean something's paid, so I'm going to go rediscover the state. So that's obviously no good for the real world where we have to notice it. So one thing you'll notice over here is every couple seconds there's a heartbeat being sent. So the twisted server here just has on a timer a heartbeat message, which goes and says, hey, is there anything new to discover? Is there anything new to discover? So just one quick example. So right now, this client doesn't see any pieces of art. So one new element is just for sort of like the super user adminning, so me operating this app in the real world. I got to curate the art, make sure there's no porn or something attached or included in the art. So I got to actually attach each piece of art. So I did that. So what just happened there is the heartbeat saw that this piece of art was now attached, and then it advanced to grab the state of that art, and then it told the clients that are connected, hey, there's this new piece of art. So if I go and attach another piece of art, there's Crypto Pepe. So again, we did an attach, and then on the next heartbeat, it found, hey, there's something new I need to take into account. I might advance. So that's just based on what pieces of art are attached to the back end. But then what's more important is the actual payments. So if I go into a piece of art, so if I want to go invoice a pixel, say pixel 55, I'm going to invoice. So yeah, that goes through, we get the Bolt 11. Now yeah, this is sort of the cheat. So what I'm going to do is I'm not going to click this button. So I'm going to take the C invoice label, the thing that corresponds to that UUID of this invoice as far as the daemon's concerned. So I'm going to go, so I have this mock C Lightning here. So it's meant to behave very much like C Lightning, but just for like unit test purposes and kind of this development. So I'm not actually paying real money and having to run the entire daemon and all that and worry about the state of that. I can just kind of mock it really quick. So here in this daemon, I just did a list invoices like you would on C Lightning, and it just dumped all that, and so it knows, hey, there's this invoice that's been created, it's currently unpaid, and there its label, which is the one I created. If you're curious about C Lightning, I should just mention this is all on GitHub at that that URL. It's just a very simple piece of Python here, and I have some documentation of how to use it. It's very basic. It's not full featured, but it's good enough for me for my development right now. So yeah, what we need to do is we need the application to notice that this thing has been paid out of bound, or out of band from what it's doing. It's just, it has to go check on the daemon. The daemon that has to say, hey, it's been paid, and then the application has to respond accordingly. So I can do mark paid on that guy. So when I mark it paid, the heartbeat should discover that, hey, there's this new pixel that's been paid for, and then we gotta discover it and then report that out to the clients. So I'm gonna do that. So I've marked it paid. Let's see. Okay, yep, so the heartbeat discovered that it existed. It advanced to go grab the new state for this piece of art because it detected that this piece of art was out of date, and then it incorporated that up in the server. So it propagated up to the server, and then the server sent it all out to all the connected clients, and then such that we got that pixel there. And then if I just try marking paid, it just becomes a no-op. Yeah, so one thing you might notice is it's kind of slow to respond. That's fine. I mean, paying the invoice, at least with the current state of the Lightning Network, takes a sec. So super responsive. I can increase the speed of the heartbeat, I guess, and it would be more responsive. I guess maybe alternate designs. To add a component that can kind of stay in very tight sync with C Lightning, and then every time there's a new change of state for the paid, you could go poke and say rediscover it, just so that it's not waiting for the heartbeat time to actually find it. We could actually find it, if this is only happening every 2 or 3 seconds, we could find it within a quarter second or something. Maybe that would be better. It's kind of a lower priority concern right now. I mean, that's still not perfect, in that if we discover that there's some new paid invoice here on C Lightning, we'd have to queue a new command onto the back end to say, hey, there's something else here. So if there's other stuff going on at the same time, it's still got to sit, it's still got to be processed in due course. So it might be, partial seconds, or even a couple seconds if it's really busy before it actually gets processed. So it's still not fully push. It's an improvement anyway. So one thing I do have implemented in here is, for example, if we're getting state, if we're getting the full state of the art, before it just pulls it blindly off disk, I have it so it goes checks before it pulls to see if there's any new invoice, and then updates before it actually allows the pull to happen. And that just ensures that, within that split second, we know that the state that's delivered is totally in sync, rather than delivering some out-of-state state and then having to catch up on that based on new paid invoices. Okay, so I'm going to split this video into another one. I'm going to talk about scaling next. That's all I had to cover, but I will continue this on the next video, and then in the future hopefully have more videos as well as I continue development.